What's up, Simpsonites? I wanted to bang out a quick vid for you. I don't really have time to go over the whole test tonight, but I wanted to do the mole or grams to grams conversion number 6 on the test. And we've done a few of these in class, but I just want to give you something to go back to and look at. So I wrote out the balanced equation here. Hopefully you can balance an equation. We got our oxygen diatomic here, and we balance it. So we have hydrogen peroxide, H2O2, decomposing into water and oxygen gas. Okay, our known right here is 40.6 grams of hydrogen peroxide, H2O2, and our unknown is how many grams of water are we going to have given that many grams of H2O2. So let's break this down. I like these problems because there are 3 conversions in one, and you have to use a few different conversion factors. So let's break that down first. Let's call H2O2A, and let's call water B. Okay, so we're starting here. Our known is given to us in grams of A, right? And at the end of the day, we want to get into grams of B. But you can't just go directly between these two. You cannot go from grams of something to grams of another thing without multiple steps in between. So let's work backwards a little bit. So if we're trying to get here to grams of B, okay, if we want to get grams of B, what units do we need to be in order to convert into grams of B? What can we go directly into grams from? What needs to go here, in other words? What units need to go here? Think about that for a second. Pause the video if you have to. Ready? You ready? All right, let's do it. So we need to be in moles, okay? Because we can go from moles to grams using the molar mass. We can always go from moles to grams and vice versa using the molar mass. Okay, because molar mass is given to us in grams per mole. And in itself, that's a conversion factor. When you have whatever the grams are for the molar mass for a certain thing per 1 mole, that's a conversion factor that you can use. So we need to be in moles of B in order to get into grams of B. All right, now how are we going to get to moles of B from grams of A? All right, well, we have to be in moles of A. I have more space than I thought. All right, so we're going to have to be in moles of A, go to moles of B to get to grams of B. So overall, we start with grams of A. Okay, again, using molar mass. Each arrow here is a conversion factor, by the way. Each of these 3 arrows is a conversion factor. So using the molar mass here, we can go from grams to moles. Okay, then we're in moles of A. But we're still trying to get to grams of B. Okay, so our next step is going to be to get into moles of B using this conversion factor, which is molar ratio. All right, so one example I've used before is if you're making a s'more. All right, so if I'm making a s'more, I know that I need 2 graham crackers and 1 chocolate bar. I forget the marshmallow for now, I don't feel like writing it out, to get 1 s'more. Okay? So, how many graham crackers per s'more? How many graham crackers per 1 s'more? Well, you just look at the numbers. For every 1 s'more, you need 2 graham crackers. That's a ratio. Okay, and it's the same thing with an equation. To get a molar ratio, you just look at these numbers out front. Same thing. Okay, because those ratios out in front of an equation are the moles. Essentially, you could break it down into molecules. It takes 2 molecules of H2O2 to make 2 molecules of water, but we measure things like molecules and atoms in moles. So this is saying 2 moles for every 2 moles, and 2 moles of H2O2 for every 1 mole of O2. All right, so let's get into the actual solving of it. So our first conversion factor here, right here, is going to have to get us from grams of A, which is H2O2, into moles of H2O2. So we need the molar mass of H2O2. How do we get that? Well, we break it down. H twice, O twice, 0.01, 16, okay, so 2.02, 32, so we get 34.02 grams per mole. And this grams per mole is huge because that is the same as saying, or we can just write it differently, like this. Grams of H2O2 for every 1 mole of H2O2. And we have our first conversion factor. We have this conversion factor. Check. It's an ugly check mark. Okay, and then we need to go, that'll enable us to get into moles of H2O2. Now we need to get from moles of one thing to moles of another. So there we just use the molar ratio, like I just talked about from the s'more example. So for this one, we're going from H2O2 to H2O. So here's H2O2, here's H2O, and here are their ratios. It's 2 to 2, or 1 to 1. So for every 1 mole of H2O2 that reacts, I'm going to produce 1 mole of H2O. All right, that's it. That's this conversion factor right here. Using this is going to allow me to go from moles of A to moles of B. And obviously, it's going to be the same amount of moles because it's a 1-to-1 ratio. Now lastly, I need to go from moles of water to grams of water. So water is H2O, so H twice, oxygen once, 1.01, 16, and I was going to say I was going to get 17, that's not the mass of water. Hopefully you caught that, should be 2.02, 18.02 grams per mole, which again is crucial because we can say 18.02 grams of water for every 1 mole of water. Okay, now we have our 3 conversion factors that are going to allow us to do what we need to do here. So let's write this whole thing out. And I'll do this train track method. I haven't shown this to you guys very much, but some of you might find it helpful. Okay, it's the same as what we've done every other time, but some people like it. So we're starting with 40.6 grams of H2O2. I don't like how small I made my space here. H2O2. Okay, that's what we're starting with. And you can put a 1 down here, and we put 1 here, and it's a unitless 1 because anything over 1 equals itself. So you don't have to put this 1 here, but some people like to have a fraction for everything in their math. So everything over 1 equals itself. So this is just a space holder, really. We're not putting any units here. It is not moles. That wouldn't make sense. It's not grams per 1 mole. It's just a unitless 1. All right, so we have grams of H2O2 in our numerator here. So we know that we need grams of H2O2 down here because then it'll cancel. It always has to go to the denominator to cancel. Get rid of something, you drop it like it's hot. Drop it down to the denominator to kill it. Okay, so this is where we use our molar mass of H2O2 because we're trying to go from grams to moles. So up here, we want moles of H2O2. So we know from our conversion factor, we just have to take this and flip it. 34.02 grams for every 1 mole. All right, that's our first conversion factor. Okay, so that's going to allow us to cancel out grams. Now we want to cancel out moles of H2O2, so that goes down here. And we want to go into moles of water, so that goes here. And that's our conversion factor right here. 1 mole to 1 mole. All right, so that's our second conversion factor. And through that, we're going to cancel moles of hydrogen peroxide. Okay, and then our last conversion factor, we want to go get rid of moles of water because we want to end up with grams of water. So drop it like it's hot. So we take this conversion factor right here, 18.02 grams for every 1 mole. Okay, and that's our last conversion factor. So this is going to allow us to cancel this. So to review the math itself, first I cancel grams of H2O2, then I cancel moles of H2O2, then I'm in moles of H2O, then I cancel that, and I'm left with grams of H2O. So then you do the math out, so it's going to be 40.6 divided by 34.02 times 1 over 1, which will stay the same, and then times 18.02. I don't remember the answer, but I guess I'll do the math live real quick. So 40.6 divided by 34.02 times 18.02. Okay, so I did this out. I got 21.5. Let's look at our significant figures here. We have 3 here, so I'm just going to leave it at 3. 21.5 grams of H2O. And units are always very important. Okay, so some of you would mess up your units at the end, even though you got the math right. We canceled everything, and then we were left with just grams of H2O, which is what we were looking for. Okay, so that is a grams to grams conversion. It involves 3 separate conversion factors and 3 separate steps to go between the units you need to go between.